Hello students, welcome to lecture 4 of S block group 2 elements. Already we discussed about that first group elements in previous lectures. Now we are going to discuss about group 2 elements. And this group 2 elements are also called alkaline earth metals. The group 1 elements are also called alkali metals. And group 2 elements are also called alkaline earth metals. The second group elements also called alkaline earth metals except beryllium. Because they can form alkaline solution when they react with water. If the second group elements react with water, they can form alkaline solution. So that's why the second group elements are also called alkaline earth metals except beryllium. And the second group elements are beryllium, magnesium, calcium, strontium, barium, and radium. Next, electronic configuration. All second group metals have two valence electrons. So their common outermost electronic configuration is Ns2. The first group elements common outermost electronic configuration is Ns1, and second group elements common outermost electronic configuration is Ns2, and they can easily lose their two valence electrons. Then they can form divalent ion M+2, and the first group elements they can form monovalent ion M+, and the second group elements they can form divalent ion M+2. Next, element symbol and electronic configuration. The first element is beryllium, and its symbol is Be, and atomic number 4. Then its electronic configuration is 1s2, 2s2, because it contains 4 electrons, 1s2, 2s2. Or also we can write that 1s2 means it reaches helium electronic configuration, and the remaining one 2s2. And next element magnesium, and its symbol Mg, atomic number 12, and for that 12 electrons the electronic configuration 1s2, 2s2, 2p6, 3s2. Or we can write up to here 10 electrons means neon and 3s2. And next one, the third element calcium, and its symbol Ca, its atomic number 20, and for the 20 electrons electronic configuration, so it contains 20 electrons. For that 20 electrons electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Or also we can write that argon, and the remaining 4s2. And next element strontium, its symbol Sr, and its atomic number 38. So it contains 38 electrons, and its electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, and 4p6, 5s2. Or we can write krypton, and the remaining electrons 5s2. The next one, barium, and its symbol Ba, atomic number 56. It contains 56 electrons. So for that 56 electrons, electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 4d10, 5s2, 5p6, 6s2, or we can write that xenon and 6s2. And next element, radium, its symbol is Ra, atomic number 88. So for that 88 electrons, electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p6, 4d10, 4f14, 5s2, 5p6, 5d10, 6s2, 6p6, 7s2, or we can write that radon and 7s2. So this is the electronic configuration of second group elements. So the second group elements common outer electronic configuration is ns2. So here the outer electronic configuration for beryllium 2s2, magnesium 3s2, and calcium 4s2, strontium 5s2, barium 6s2, and radium 7s2. So the common outer electronic configuration we can write as ns2. And in this second group elements, the radium is a radioactive element. And next one, atomic and ionic radii. With the increase in atomic number, the atomic size increases. Then atomic radii also be increases. With the increase in atomic number, the atomic size increases. Then atomic radii also increases. When we go from beryllium to barium, the size increases. Then atomic radii increases. If you take that second group elements size, this is the beryllium and magnesium, calcium, strontium, and barium. So it is a beryllium, magnesium, calcium, strontium, barium. So if you go from beryllium to barium, the size increases. Consequently, the atomic radii increases. And the alkaline earth metals are smaller than the corresponding alkali metals in the same period. So if you take same period elements, the alkaline earth metals size is smaller than the alkali metals. So this is the periodic table. This is the first group and this is the second group. So if I take same period elements, for example, so here I am taking second period. In second period, the first group element is lithium, and in the same period, the second group element is beryllium. So here the alkaline earth metal beryllium size is smaller than the alkali metal of lithium. So the lithium size is more than the beryllium. It is due to the increased nuclear charge. So if you take that lithium, so that lithium is the first group element and beryllium is the second group element. So these two are belongs to same period. So that is second period. And in lithium, the number of protons are 3. Protons means positive charges. Because its atomic number is 3. Total number of electrons 3 and number of protons also 3. And beryllium atomic number is 4. So in the nucleus there are 4 protons, means 4 positive charges. So here this is the lithium and this one is the beryllium. So in the lithium we have 3 positives and in the beryllium we have 4 positives. So in orbits there are electrons. So the electrons charge is negative. So that electrons are attracted towards the nucleus because in that nucleus we have positive charges. So here in beryllium there are 4 positive charges, but in lithium there are only 3 positive charges. So in beryllium the electrons are strongly attracted towards the nucleus, then the size will decrease. So here the beryllium size is smaller than the lithium. And the divalent ion M+2 is smaller than the parent atom. For example, I am taking the magnesium. So Mg+2 is the divalent ion and Mg is the parent atom. So Mg+2 is smaller than the Mg, because if you take that magnesium, the magnesium atomic number 12 and the total number of electrons in magnesium is 12. So for that 12 electrons, the electronic configuration 1s2, 2s2, 2p6 and 3s2. So this is parent atom. And if you take ion, the divalent ion, +2 means it lost 2 electrons. So it lost 2 electrons. The 2 electrons lost from 3s. So then the electronic configuration 1s2, 2s2 and 2p6 only. So this is for Mg+2. So here this is the Mg. So in that Mg we have first shell and second shell 1 and 2. So this number is the principal quantum number. The principal quantum number shows the orbit number. So first orbit, second orbit and third orbit. So there are 3 orbits. First, second and third. In third orbit there are 2 electrons. And if you take Mg+2, so this is the Mg+2, and in this Mg+2 we have only 2 orbits, 1s and 2s 2p. So these 2 are present in second orbit and this one is present in first orbit. So first orbit and second orbit. So there is no third orbit. So here if you see the size, the Mg+2 size is small than the Mg. So that divalent ions smaller than the parent atom. Next one, ionization enthalpy. The alkaline earth metals having low ionization enthalpies. Low ionization enthalpies. If you go from top to bottom in a group, means if you go from beryllium to barium, the atomic size increases. Already we discussed that. Atomic size increases. Then their ionization enthalpy decreases. So here if you go from beryllium to barium, the atomic size increases, then the ionization enthalpies decreases. So the beryllium having high ionization enthalpy than the barium, because here the more energy required to remove the electron from outer shell. But here if you take the barium, so there is a more distance between the nucleus and outer shell. So here less energy required to remove the electron from outer shell. So the beryllium having more ionization enthalpy and the barium having less ionization enthalpy. If you go from beryllium to barium, the ionization enthalpies decreases. And the first ionization enthalpies of alkaline earth metals are higher than the corresponding alkali metals. And here the first ionization enthalpy and second ionization enthalpy. And here I am taking first group and second group. The first group, first ionization enthalpy less, and second ionization enthalpy more. And second group, first ionization enthalpy more and second ionization enthalpy less. So the first group elements having less first ionization enthalpies than the second group, and first group elements having more second ionization enthalpies than the second group. Let me take one example here. I am taking same period, the first group and second group, same period. Here I am taking third period, first group element sodium, second group element magnesium. So here first ionization enthalpy for sodium is less than the magnesium, because the sodium atomic number is 11. So it can form Na plus by lossing of one electron. Now that Na plus is stable because it contains 10 electrons, means it reaches neon electronic configuration. So it can easily lose one electron to form Na plus. Consequently, it requires less energy. And if you take a magnesium, the first ionization enthalpy is more than the sodium. So the magnesium atomic number is 12. So if it lost one electron, then it will form Mg plus. Now it is not stable, but here it is stable. That's why it requires more energy than the sodium. And if you take a second ionization enthalpy, so here the energy required to remove one more electron is called second ionization enthalpy. So here already it lost one electron, then it will form Na plus. So if it is lost another one electron, then it will form Na plus 2. But it is impossible because already it's stable. It reaches the neon electronic configuration. So it is impossible, and it requires more energy to remove the second electron. Then if you come to that magnesium, so here magnesium lost one electron, then it will form Mg plus. So it is a first ionization enthalpy. So here the energy required, that energy is called first ionization enthalpy. So to remove one more electron, the energy is required, that energy is called second ionization enthalpy. So here it will lose another electron, then it will form Mg plus 2. So here Mg contain 12 electrons, Mg plus contain 11 electrons, and Mg plus 2 contain 10 electrons. So here this Mg plus 2 is more stable because it reaches the neon electronic configuration. So here less energy is required to remove the electron, means the second ionization enthalpy is less. So first ionization enthalpy is less for first group element than the corresponding second group element. But second ionization enthalpy is less for second group element than the corresponding first group element. This is about ionization enthalpy. Next one, hydration enthalpies. The energy released when 1 mole of ion react with the water is called hydration enthalpy. So there is a 1 mole of ion, second group ion. So this ion react with water. So in this reaction, the energy is released. This energy is called hydration enthalpy. And the hydration enthalpies of alkaline earth metals decreases with increase in the size. So if you take that second group metal ions, beryllium +2, magnesium +2, and calcium +2, strontium +2, barium +2. If you go from beryllium +2 to barium +2, the size will increases. So if the size increases, then the hydration enthalpies decreases. So here Be+2 having more hydration enthalpy than remaining metal ions, and magnesium +2 having more hydration enthalpy than remaining metal ions, but it contains less hydration enthalpy than beryllium +2. So this is the decreasing order of hydration enthalpies. So beryllium +2 having more hydration enthalpy and barium +2 having less hydration enthalpy. And the hydration enthalpies of alkaline earth metal ions are larger than those of alkali metals. So alkaline earth metals having large hydration enthalpies than the alkali metal ions. Alkali metal ions means second group metal ions having large hydration enthalpies than the first group metal ions. And compounds of alkaline earth metals are more extensively hydrated. More extensively hydrated than those of alkali metals. So here I am taking hydrated compounds of first group metals and second group metals, means alkali metals and alkaline earth metals. First group metal hydrated compounds, for example lithium chloride, so 2H2O, lithium chloride 2H2O, so it is a lithium chloride hydrated compound. So here only 2 H2Os. And here I am taking second group hydrated compounds, magnesium chloride 6H2O and calcium chloride 6H2O. So magnesium and calcium are belongs to second group and lithium belongs to first group, means alkali metals, and these two are alkaline earth metals. So here alkaline earth metals are more extensively hydrated 6H2O 6H2O than those of alkali metals. So here only 2H2O. So this is the hydration enthalpies. Next one, physical properties of second group elements. So the alkaline earth metals, means second group metals, are silvery white color. Silvery white. and they are soft but harder than the alkali metals, but harder than the alkali metals means first group metals. And beryllium, magnesium are grayish color, and the melting point and boiling points of the second group metals are higher than the corresponding first group metals due to the small size. So the second group metals having high melting and boiling points than first group metals due to the small size, and they are strongly electropositive in nature. Strongly electropositive in nature. And the electropositive character increases from the beryllium to barium. Beryllium to barium. And the calcium gives brick red color to the flame. Brick red color. And strontium will give crimson color to the flame. And barium will give apple green color. Apple green color to the flame. So these are the physical properties of second group elements.